Good day, engineers. So, para sa video natin ngayon, ang i-discuss natin is about the sample problem number 2. So, this is still for the Coulomb sloping backfill na problems. So, simulan natin by discussing what is stated in the problem. So, a 4.5 meter high retaining wall supports a backfill slope at an angle of 10 degrees from the horizontal. The backfill has a unit weight of 18.8 kN per cubic meter and an angle of shearing resistance of 22 degrees. If the retaining wall is inclined at an angle of 65 degrees from the horizontal and the angle of friction of this wall is 20 degrees, determine the following. So first, the active force on the wall. Second, horizontal active force on the wall. The third is the passive force on the wall. And the fourth will be the horizontal passive force on the wall. So, simulan natin yung problem by drawing its figure. So, ito siya. So, meron tayong figure na dyan for our backfill. Sabi natin doon, it is inclined at an angle 10 degrees from the horizontal. Ito. Then, meron daw tayong inclination ng retaining wall from the horizontal, which is 65 degrees. Then, meron daw angle of wall friction of 20 degrees. And sabi natin, meron tayong angle of internal friction of 22 degrees, which is siya yung angle between the normal force and the resultant force nung kinokos ng failure wedge natin na W or nung weight ng failure wedge natin na W. Then, yung retaining wall natin is 4.5 meters high. So, for this problem, we will be using the Coulomb earth coefficient equations para ma-solve yung mga conditions na hinahanap niya. So, let's first start by getting the value of the active and passive earth coefficient. Siyempre, sabi ko nga, mag-start tayo na i-store natin sa A, B, C, and D yung mga values na kailangan natin dito. So, siyempre, meron tayo dong alpha, which is 65 degrees. And ito yung gagawin nating A. Next is yung phi, which is 22 degrees. And siya yung gagawin nating B. Then, meron tayong small delta, which is yung 20 degrees. Yan yung angle of friction ng wall. Yan yung magiging C natin. And meron tayong beta, which is the 10 degree angle. At yan yung magiging D natin. So, yung beta, yan yung slope nung backfill natin. So, we'll start by getting the active earth coefficient. So, the active earth coefficient will be equivalent to a value Ka is equal to the sine squared A plus B, so divided by the value sine squared A, then that is sine A minus C times 1 plus square root ng, so that is sine B plus C sine B minus D divided by sine A minus C times sine A plus D. So this one will be a value squared. So using our calculators in getting the active earth coefficient, so yung calc function ng calculator natin, we could have a value of Ka equivalent to, so isin natin, that will be Ka. So that is Ka is equal to 0.8152. So, yan ngayon yung active earth coefficient natin. Then, we proceed to the passive earth coefficient. So, sa passive earth coefficient natin, we have an equation, K sub P is equal to, sub natin ditong kaunti. So, that will be sine squared A minus B divided by sine squared A sine ng A plus C times 1 minus square root ng sine B plus C sine B plus D divided by sine ng A plus C sine A plus D. Then this will be squared. Then, using ulit yung calc function ni calculator, we can have a value of Kp equivalent to 3.681. So, yan na ngayon yung active and passive earth coefficient natin for our given problem. So, we'll start calculating the active condition for the soil. So, we'll start with the active condition. So, for the active condition, so we can have our active pressure, which is equivalent to the gamma times H times Ka. So that is equal to a value 18.8 times the height 4.5 meters times the Ka, which is 0.8152. So our pressure will be equivalent to a value 68.9659. So this value is in kilopascal. Now, syempre, to get the active earth force, we can have F sub A, which will be equal to a triangular pressure diagram. So, ang area nun will be 1/2 times P sub A times the height. So, that will be equivalent to a value of 1/2 times P sub A, which is 68.9659 kilopascal times 4.5. So, calculating this one, we could get a value of Fa, which is equivalent to 155.1733. So, this is in kilonewton per meter. So, ito na yung isa nating hinahanap na earth force, which is in the active condition. Sunod nating hanapin yung pinapahanap niya na horizontal active earth force. So, para makuha yun, kakailanganin natin yung inclination nung retaining wall natin. So, kung ito yung face ng retaining wall na sumasalo dun sa soil, syempre, nasa active condition tayo. So, meron kang force na normal dito. So, ibig sabihin, this is a 90-degree force. And we call this one as the F of the active force, which is normal. Ngayon, syempre, since yung soil mo is, ang failure niya kapag active condition is pabagsak papunta dito. So, ibig sabihin, pasalo yung gagawin nung retaining wall. So, that means, meron kang force na papuntang paganito. And that is our active force. And the distance or the angle between the active force and the normal active force is a value 20 degrees, which is the angle of friction of the wall. So ngayon ang hinahanap natin is yung horizontal force. So we'll draw a horizontal line from this given. So as you can see, pag nag-draw tayo ng horizontal line, may mabubuo tayong angle which is ito, and it corresponds to an angle 65 degrees. Kasi alam natin that the angle on this side, or the angle of inclination of the retaining wall, is also 65 degrees. As you can see, para makuha natin yung unknown dito, we will be needing a value theta 1 which will be added to 20 degrees para yun yung maging part nung angle in between FA horizontal and the active earth force, kasi ito na si FA horizontal. So we will be needing an angle theta 1. So to get theta 1, as you can see, we can have it this as, kasi 90 degrees na to mula dito papunta rito. So ibig sabihin, yung 90 degrees ima-minus natin sa 65 degrees, which is corresponding to a value of 25 degrees. So yan na ngayon yung theta 1 natin. So para makuha na natin yung FAH na nandito, which is the horizontal component of the active force, so we can have FAH is equal to, so syempre, dun muna tayo sa function. So kapag ginamit natin yun, that is, or kapag kukunin natin yun, that will be a cosine function. So ibig sabihin, the cosine of angle theta 1 plus 20, kasi ito yung angle na yun theta 1 plus, that is theta 1 plus 20. So that is equivalent to a value. So yung hinahanap natin na FAH divided by yung hypotenuse na FA. So that will be equivalent now to an equation FAH is equal to FA cosine ng theta 1 plus 20. Substituting the values, we can have 155.1733 cosine 25 plus 20. So we can have a value of the horizontal component of the active force, which is 109.7241, which is in kilonewton per meter. So ito na ngayon yung hinahanap natin na horizontal component of the active force. Now we proceed to the passive condition. So this will be now for the passive condition. So for our passive condition, syempre unahin muna natin kunin yung pressure or the passive earth pressure. So to get the passive earth pressure, syempre that will correspond to P sub P, which is equivalent to gamma H Kp. Yung gamma natin will still be 18.8 times the height, which is times 4.5, sorry, times yung Kp, which is 3.681. Now we have a passive pressure equivalent to 311.4126. So this is in kilopascal. Now getting the passive earth force, F sub P. So syempre triangle diagram pa rin to. So that will be 1/2 P sub P times H. So that will be equivalent to a value which is equal to 1/2 times 311.4126 times 4.5. So we can have a value of the passive force equivalent to 700.6784, which is in kilonewton per meter. Ito na ngayon yung passive earth force natin na hinahanap for the given problem. So the next one will be yung horizontal component ng passive earth force na to. So syempre babalik ulit tayo dun sa face ng retaining wall. So kung ito yung face, and alam natin that is inclined at an angle 65 degrees. So syempre meron ka pa rin dong normal force, ito. Then syempre this normal force, so inclined natin ng kaunti. Exaggerate natin yung incline. So syempre yung normal force, ito. Then syempre yung passive earth dyan is naka ganito. So andito yung passive earth. This is FP normal, tas ito yung FP natin. So this one is an angle 20 degrees. Ngayon alam natin this is a 90 degree angle. So mula dito hanggang dito 90. Pinating blue. Then, ang hanapin natin is yung horizontal component. So, syempre, pag kukunin natin yung horizontal component, draw ka ng horizontal line. So, let's say, ayan yung horizontal line. So, as you can see, yung horizontal line na yun ulit, syempre, ito is 65 kasi parallel siya dun sa base ng retaining wall natin. So as you can see, meron tayo ditong angle in between which is theta 2. Gawin natin theta 2. And meron tayo diyang angle which is ito. Ayan. And that will be theta 1. So ang una nating mahanap dyan ay yung theta 1. Si theta 1 will always correspond to a value 90 minus 65. Kasi galing siya dun sa normal force and papunta dun sa angle nung or yung inclination ng face ng retaining wall. So that is 90 degrees. Meron tayo nitong value na 65. So ideduct lang natin yun, makukuha natin si theta 1 which is still 25 degrees. Ngayon as you can see, kung ito si theta 1 at yung hinahanap natin is si theta 2 na yung maliit doon, so ibig sabihin, we can have theta 2 equivalent to a value theta 1 minus the 20 degrees. So that is equivalent to 25 minus 20. So our theta 2 will be 5 degrees. And yan na ngayon yung gagamitin natin para mahanap yung horizontal component nung passive earth force. So that will be cosine of theta 2 is equivalent to a value FPH divided by the passive earth force. So that is a cosine function. So arranging this term, we can have FPH equal to FP cosine ng theta 2. So FP will be equivalent to a value 600 or 700.6784 cosine ng 5. So we can have a value of the horizontal component of the passive earth force equivalent to 698.0121. This is in kilonewton per meter. So ito na ngayon yung final answer na hinahanap natin for the horizontal component of the passive earth force. So, nakuha na natin yung apat na required nung problem natin just by using the trigonometric function and also the principle for the Coulomb sloping backfill. And that will be all for this video. Thank you for watching. Again, this is Engineer Rodolfo. Don't forget to subscribe to Butch TV.